This is Unit 2, Lesson 6, Part 2. We are working on the product and quotient rules for derivatives. We are going to start with using the quotient rule to develop the rules for the 4 remaining trigonometric functions. Now, we did sine and cosine already in the last video, so now we're going to do cosecant, secant, tangent, and cotangent. And we want to remember, in order to do this, we want to start by rewriting each of the functions in terms of sine and cosine. And then we'll have a quotient and we'll differentiate the quotient. So let's get started. So the first one is cosecant. Now cosecant of theta is 1 over sine theta. So if we are going to differentiate, we're going to take f prime of theta, and we're going to take the value, the second function, the denominator, times the derivative of the numerator, which is a constant, so its derivative will be 0, minus the numerator times the derivative of the denominator. And this is all going to be over the denominator squared. So when we simplify this, we're going to get negative cosine theta over sine squared theta. And to simplify this, we can think of this as negative cosine theta over sine theta times 1 over sine theta. Now we can use our trig identities, and we can rewrite this to the derivative that we are familiar with, which is negative cosine theta over sine theta is going to give us negative cotangent theta, and 1 over sine theta gives us cosecant. So it's normally written in this order: negative cosecant theta, cotangent theta. So there's the first one. Next, we're going to do secant in the same fashion. So we're going to start by rewriting secant as 1 over cosine theta. So our derivative of f of theta is going to be our denominator times the derivative of the numerator, which is again a constant, so it'll be 0, minus the numerator, which is 1, times the derivative of the denominator, which is going to be minus sine theta. And this is all over cosine squared theta. So simplifying, we get sine theta over cosine squared theta. So breaking this apart and rewriting it, we're going to have 1 over cosine theta times sine theta over cosine theta. So using our trig identities, this becomes the familiar form. Secant theta is 1 over cosine times tangent theta, which is sine theta over cosine theta. Okay, next one is going to be tangent, which we can rewrite as sine theta over cosine theta. So the derivative of f of theta is going to be the denominator. The denominator times the derivative of the numerator, so that'll be cosine theta, minus the numerator times the derivative of the denominator, which is minus sine theta. And this is all over the denominator squared. So simplifying this, we get cosine squared theta plus sine squared theta over cosine squared theta. Now hopefully you recognize the Pythagorean identity. So f prime of theta simplifies to 1 over cosine squared theta, and 1 over cosine theta is secant theta, so here comes our familiar form of the derivative of derivative of tangent, which is secant squared theta. And then finally, our cotangent, we want to start by rewriting this as cosine theta over sine theta. Now we can take the derivative of f of theta. So sorry about that. It's because I'm so close to the edge of the program. F prime of theta is equal to the derivative of the numerator times the denominator. So we have sine theta times negative sine theta minus the numerator, which is cosine theta, times the derivative of the denominator, which is cosine theta. And that's all over the denominator squared. Okay, simplifying this, we get negative sine squared theta minus cosine squared theta all over sine squared theta. Now, hopefully you can see that if we factor out a -1 from the top, we have our Pythagorean identity of sine squared theta plus cosine squared theta. And that's all over sine squared theta. So we can simplify this to -1 over sine squared theta, and using the quotient identity, or the reciprocal identity, excuse me, this becomes negative cosecant squared theta. So there's where the 4 other trig derivatives come from. All right, so you want to make sure that you memorize all these. So of course we have that the derivative of sine is cosine theta. The derivative of cosine is minus sine theta. The derivative of tangent is secant squared theta. The derivative of cosecant is negative cosecant theta, cotangent theta. The derivative of secant is secant theta, tangent theta. And then finally, the derivative of cotangent is negative cosecant squared theta. And hopefully, one way I always remember them is any derivative of a its derivative is negative. And they're always along that line. I mean, like secant, I repeat the secant, and tangent usually goes with secant because neither one of them are cos. The cos go together. I mean, there's little ways you can remember them. Okay, so next, something else, before we get more derivative techniques, is sometimes it's easy to decompose the function before you use your constant multiple rule to rewrite it, and then you can take the derivative. So the first one, if I rewrite the first one, I can think of this as y equals x minus 4 to the -1/2 power. Now I can differentiate that and simplify it. So y prime becomes, can kind of use the power rule here, and this is a special case, and we're going to talk more about this later on in the next unit when we talk about something called the chain rule. So this becomes, I subtract 1 from the power and I get -3/2. So simplifying this becomes -1 over 2 times x minus 4 to the 3/2 power. Okay, so for the next one, because I can separate this into 2 separate terms. And when I do that, the first term is going to have a common x that I can simplify anymore. So I'm going to get 6x to the 3/2 minus x to the -1 e to the x. So I can use the product rule on the second part and just the power rule on the first part. So y prime becomes 6 times the 3/2 x to the 1/2, and then using the product rule minus, I'm going to put the whole thing in parentheses because the whole thing is going to be subtracted. So I take the derivative of the first, which is going to give me -1 over x squared times the second plus the first times the derivative of the second. and then simplifying everything, I get a final answer of 9x to the 1/2, or you can use the square root, plus e to the x over x squared minus e to the x over x. And also, if you want to factor out the e to the x, you can do that. There's different ways to write the final answer. It just depends on what's being asked for. Okay. And then finally, the last one of this set. Again, I can separate this into 3 separate fractions and simplify it. So y then becomes 6x to the 7/2 plus x to the 5/2 minus 2x to the 1/2. Now I'm just going to use the power rule and simplify, so I get y prime equals 21x to the 5/2 plus 5/2 x to the 3/2 minus 1 over x to the 1/2. And that's fine. You don't have to simplify it any more than that. Okay, so now one last part of this section is going to be about higher order derivatives. So we're going to talk about that. And I've mentioned this in class, how they are related to each other in terms of application problems. So I will finish this in the third part of the video. And this section is good to have separated because the last section of the unit talks about using those second order derivatives using velocity and rates of change.